Hello, class. So yesterday or not yesterday, last class, you got to look at the nucleus, right, and how that all fits together. And that simulation also had you putting electrons in. I looked at a lot of your work. You guys did really well. Uh, but today we're going to talk about where are these electrons going and why are they going to the places that they're going in, right? Um, and I also wanted to let you know that I will be there next week, so we won't have to do the online lessons anymore. I'm very excited to meet all of you in person finally. Uh, yeah, so that's really good news. But today, electrons, right? Electrons are super duper important. We know that the protons and the neutrons are sitting in the center, right? Protons are kind of defining what element we have. Um, But the electrons are the thing that is going to be interacting with other elements and other atoms, right? Because they're on the outside and they're moving around. So they can get exchanged, they can get shared, right? They can get stolen or given. So it's super important to understand electrons and how they look for each element. Um, each element has electron shells, and each shell can hold a specific number of electrons. Different elements have different numbers of electrons, right? So right here we have sodium, and we could count up all its electrons, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Or potassium, right? Potassium has, let's see, 2, and then there's 8 in this ring, and 8 in the next ring, plus one more, that would be 19, right? So each element is going to have a different number of electrons, and the electrons um, arrange themselves in a very specific way around the nucleus in these shells. So we need to learn how to do this, right? So electron configurations basically are the idea that electrons are arranged in shells around the nucleus. And the shell you can think of as like the space that the electron occupies, right? So the inner shell is occupied first. The spaces closest to the nucleus are where the electrons are going to go first. They want to be close to the nucleus because the electron is negative, the nucleus is positive. They are attracted to each other through the electromagnetic force, right? So they will go as close as they can. Each shell is going to hold different numbers of electrons. The first shell can only hold 2 electrons. So there can only be 2 electrons in this first shell that's really close or relatively close to the nucleus, right? The second shell can hold 8 electrons, up to 8. It doesn't have to hold 8. If you don't have enough electrons to fill it, there obviously won't be 8, but it can hold up to 8 electrons. And each shell after that can hold up to 8. Um, this is true for the first 20 elements, and that's what we're going to focus on. After that, it gets a little bit more complicated, but we're just going to focus on the first 20 elements to really cement this idea. So, first shell holds 2, second holds 8, and each shell after that can hold up to 8. Right? So we have hydrogen with 1, neon with 10, calcium with 20. Right? Why do electrons fill into shells instead of all gathering near the nucleus? Right. So I mentioned earlier, electrons are negative, protons are positive. They want to be close to the nucleus. Why? Let's like think of these two, right? Neon, calcium. There's a bunch of electrons. Why don't they all just hang out next to the nucleus? Take a second to think about that. Maybe talk to your neighbor about it, and then we'll talk about it. So, Um, as you get into quantum theory, that it gets a little bit messier when we get into the nitty gritty of it. But right now, I just want you to think about the electrons um, as being these negative charges, right? And they are moving around outside of the nucleus. And as you put more and more of them um, around a nucleus, what is going to happen? What happens when a negative charge and another negative charge um, get close to each other? Those charges repel, right? Like charges do not like each other. They're not attracted, they repel. So you get an electron next to another electron, they will push against each other. So there is this space around the nucleus, right, where these first two electrons are moving. And then as we add more, they would like to be closer, but it would actually take more energy for them to be closer to the nucleus than to sit a little bit further out and occupy this space, right? So it's actually easier for the electrons to sit a little bit further out because they're being repelled by these other electrons that are closer to the nucleus, right? Um, so it's actually energetically easier for these electrons to be further out than closer in because of the repulsive force between all these. Um, and these shells actually have a bunch of cool shapes. We're not really going to look at them in this lesson, but they do have cool, interesting places that they are orbiting around the nucleus. So, hydrogen. A hydrogen atom has an atomic number of 1 and therefore has 1 electron. So the atomic number, the number of protons, will tell you how many electrons you have in your element, right? In your neutral element, if it hasn't lost or gained any. You have 1 proton, you will have 1 electron. That means hydrogen has 1 shell where that first electron goes into. So if we were going to write the electron configuration, we could just write 1. There's 1 electron, it's in that first shell, right? Neon has an atomic number of 10 and therefore has 10 electrons. So if you draw neon, right, you draw that first shell, 2 electrons can go into the first shell, and then we draw the second shell, 8 electrons can go in there, and 2 plus 8 is 10, right? So that's all of our electrons. Neon has 2 shells. The electron configuration would be 2, that's our first shell, comma 8. So you write what's in the first shell, and then you write what's in the second shell. If you had a third shell, you would write what's in that. That's how we're going to write these electron configurations. So I want you now to try and write the electron configurations for phosphorus, which is atomic number 15, and calcium, which is atomic number 20. Take maybe 2 minutes. I would draw those pictures, right? That helps to draw the shells. And then write down how many shells it has and the electron configuration, which is that last little bit. So take a couple minutes and try that. So phosphorus. If we're going to draw phosphorus, it would look something like this, right? This nucleus is at the center. It has 15 electrons that we're going to fill in. So we draw our first shell. We put in the first 2 electrons. We draw our second shell. We can put in 8 electrons in our second shell. So now we have 10 total. So now we need to put in 5 more electrons. So we draw our third shell and we put in 5, right? So it has 15, which means it needs 3 shells. The electron configuration would be 2 from our first shell, 8 from our second shell, and 5 from our third shell. If we look at calcium, right, it's going to need a 4th shell because it has 20, right? So 2 in the first, 8 in the second, 8 in the third, and then it's going to need 2 in the very last shell. So it's 4 shells, electron configuration of 2, 8, 8, 2. So this is basically just telling you where your sets of electrons are going within your atom.